All right, here we go. This is Mr. Bruss checking in for the first time. Algebra 2, Chapter 3. Let's get this thing rolling here. I got a little, this is Mr. Kelly, if you didn't recognize that sweet face. There's Mr. Kelly. What's he saying here? Something hilarious, I imagine. Oh, f of x, you are so positive in everything you say or do. Because here's his function. He's the g of negative 3. What's Mr. Bean got to say about it? Absolutely. Hilarity. Mr. Kelly does it again. Look at that. He's an absolute value function. Welcome, Mr. Bean. Glad you're joining us. You'll see him later on this year with a couple of chapters. Let's get this going. Absolute values. You know, Mr. Kelly talked about this earlier. Mr. Sullivan talked about it earlier than that. Let's solve some of these things. So let's only look at the left side here. This is definitely a blast from the past here. We are so good at solving equations. So no problem when it's an equal sign, yeah? X is 4. Got that down. What happens when we throw the inequality in there? Remember we got this inequality right here, the less than, greater than sign. Nothing changes, right? It's the same rules. You follow the exact same rules. The difference is, instead of getting one answer, you're getting a whole solution set. So instead of x equaling 4, x is everything less than or equal to 4. So we're actually going to have to graph these on a number line to show all possible solutions. So when we do this, x is less than or equal to 4. We know it's less than or equal to, so it's a solid dot because it could be 4, so it's going to be this nice solid dot. And please write right on the number line. We're going to shade everything, not above, not below, everything on that line. Let's just fill that in right there. Perfect. So I'm showing every possible answer. X could be 3, 2, 1, 0, negative 1, negative 2.37. I don't know, but it's somewhere down here. Shade them all, write it right on the number line, and we're good to go. Excellent. So that's back from Algebra 1. What's going on over here? Let's check out the right side now. What happens when we throw absolute values in there? So again, we can do a little blast from the past here. Mr. Kelly actually reviewing Mr. Sullivan's how to solve absolute value equations. Holy cow. The key is what happens here when you solve for the absolute value. So do all your steps, and then what happens? You have two possible solutions. X plus 5 equals 4, or it equals x plus 5 equals negative 4. So all you have to do, because the absolute value, you're going to get two solutions here. How does it affect us with an inequality? Well, it's the same rules. You still have to solve for the absolute value. So you still do the same thing, solving for your absolute value. In this case, instead of an equal sign, it's an inequality. Divide both sides by 2. You're going to get x plus 5 is less than or equal to 4, just like above. Now, here is a slight difference. This is where it gets a little bit tricky. Because we're changing the sign, so we still rewrite the first one, x plus 5 is less than or equal to 4. No problem. But when I go ahead and say x plus 5, if I'm going to change this to a negative, I can do that. But what happens when you change it to a negative? Oh my goodness, you flip the inequality. So you get something like this. So we're not going to just change the sign. We have to actually flip the inequality. Didn't matter for an equal sign. Who cares? It's an equal sign. Flip it all you want. Still an equal sign. Now solve this. Subtract 5 from both sides. You're looking at x is less than negative 1. But come over here and subtract 5 from both sides, and you're saying x is greater than what? Negative 9. So it's a whole different thing going on here. So can I graph this? Can I be less than negative 1? But what's the key here? And I have to be greater than negative 9. So I have a nice number line drawn out for you. Let's try to draw this. Can I be less than negative 1? Find negative 1. Put a big fat dot on negative 1 because it's equal to it. How about negative 9? Here's negative 9 down here. I have to be less than negative 1 and greater than negative 9 at the same time. I'm going to shade everything in between here. So we've got a new thing, or something we haven't really talked about before. We've got a compound inequality going on here. So that's the game changer. Inequalities are more work than just equal. Here you get two answers. Here I'm going to get all the answers. Anything between negative 9 and negative 1 works. It could be negative 5.5. It could be negative 6. It could be anything in this region shaded. Holy cow, let's check it out. Check it out. Oh, there's Mr. Bean. Absolutely fired up. He's definitely always positive about this. Always positive, that guy. Let's solve this. So again, let's try another one of these. If I'm going to solve this, again, I'm trying to get that absolute value by itself. So to get rid of this divide by 2, I got times by 2. And now this is where I want to be. Boom. The absolute value of x minus 3 is less than 8. So here's a tip. How do I know what's going on here? Check this out. If you have a less than sign, doesn't matter if it's less than or equal to or just less than. I think of less than as less than. Do you get it? Less than. No? Anybody? Anybody out there like that? Let me get my highlighter because that's going to be hilarious. So there it is, less than. I'm putting the and in there. It's going to be an and. So when I split these up, I'm going to split these up. When I'm just down to the absolute value, I'm going to split this up into x minus 3 is less than 8. And I'm going to go ahead and write that in. X minus 3 is what? Flip the sign and make it a negative. So I've got two possibilities. They're connected with an and, so they've got the compound inequality connecting them together. So let's solve them. If I add 3 to both sides, no problem. I'm saying x is less than 8. And then same thing, add 3 to both sides. We're doing the same steps. X has got to be what? Greater than negative 5 when you add those together. So it's all the same steps, but this is an and. It has to be both. And remember, when I'm looking at an and, I got to graph this on a number line. I'm looking for anything that's less than 11 and greater than negative 5. So the way I really like to write it is like this. I like to say x is what? Sandwiched between negative 5 and 11. So if I do this on a number line, just go ahead and put 0 wherever you want. So I've got negative 1, 2, 3, 4, 5. There's negative 5. And I'm going to count up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's 11. So if I want to graph these together, what do I got to do? Well, it's greater than, so there's no bar underneath. So I can't include 5, so I'm going to put a circle around it. And I'm going to come out here to 11. There we go. And what am I saying? It's and. It's in between. It's everything in between here. Pick a number between negative 5 and 11. That's the solution. That'll work. Awesome. Very good. All right, excellent. Let's come over here to right and try this bad boy out over here. So again, I want to solve this, but I have to get that absolute value by itself. So I got to start simplifying until I get the absolute value by itself. So what am I going to do here? Got to subtract 4 from both sides. So do a little simplifying. Don't forget to bring your negative down. This is negative 3 times the absolute value of x plus 1 is less than or equal to, what is that, negative 21. So again, I want to get the absolute value by itself. Get rid of that negative 3 there. So I'm going to divide both sides by negative 3. So that's great. So I've got this absolute value of x plus 1. What happens when you multiply or divide by a negative, though, with inequalities? That's right, it flips. So I'm flipping it. So really, 21 divided by 3, both negatives, so that gives me a positive 7. So when you finally broke it down to the inequality, you simplified it, there's nothing else you can do. Now you're ready to say, okay, is this an and or an or? So let's go ahead and see what this one is. Aha, check that out. If it's a great or than sign, how do I remember that? I remember great or. There it is, great or than. So if you can remember that, you know I've got this greater than sign. It doesn't matter if it's equal to, it's great or than, so this is going to be an or. So let's split it. Once I know if it's an and or an or, I can say, oh sure, this is x plus 1, just rewrite it, no problem. But I know now it's going to be an or in the middle. So it's going to be or x plus 1 is now, remember I'm going to change it to negative 7. If you change to negative 7, what do you got to do though? You got to flip the sign. So I'm looking at an or. Let's solve this and see what happens. So I want to get x by itself, so I'm going to subtract 1 from both sides. We're looking at x is greater than or equal to 6. And I know it's an or. Do the same thing to this one over here. X is going to be what? Less than or equal to negative 8. So now it's just a matter of showing all possible solutions. So I'm going to do the number line. It can be anything, in wherever you want, put a 0, and I count out 1, 2, 3, 4, 5, 6. There's 6. And then 1, 2, 3, 4, 5, 6, 7, 8. There's negative 8. So I'm looking at those two numbers, and what's happening here? X can be anything greater than or equal to 6. So here it is. It can be equal to, so it's a big fatty solid dot. It's greater than, it's everything to the right, everything above it. Or it could be everything less than this. So I know it's less than or equal to, so it's a big fat dot. And I'm going to shade everything below, shade right on that number line. So ors look like that. Fantastic. Moving on. All right, so when we do these inequalities, we're making compound inequalities. These absolute values create compound inequalities. So when I have something like this, and this is a solid dot, it looks kind of weird on mine. But what's happening here? I'm saying x is what? X is, if I look at this, careful because it's counting by negative 2, negative 4, negative 6, it's counting by negative 2. X is anything less than or equal to negative 10. I know that because it's a solid dot, so it has to have the bar underneath. Solid dot, bar underneath. So it's less than or negative 10. But check this out over here. Or, what's going on? I've got x is what? It's greater than, and what is that? 14. So I put no bar underneath because it's an open dot. It can't be 14. It could be 14.0001. It could be 14.2, but it can't be 14. So it's the first number you can think of after 14, anything bigger. So it's a compound inequality. Compound means two, like a compound sentence, two parts. It has two parts to it. So that's our compound. That is an OR. How about this one over here? This one's different. Here I'm saying that x is what to negative 7? X is bigger. It's everything to the right. Doesn't include negative 7 because it's an open dot. And at the same time, x has to be what? X has to be less than or equal to 6. This is an and. When you start to smush in between, it has to be bigger than this and less than this. When they separate the opposite ways, they're or. So this is an and. And really, this is great. Like, that works. That's true. It's legit. X is any number that's greater than negative 7 and at the same time less than 6. How do we like to write that, though? We like to think about x like this. It gets sandwiched. It's all the numbers between what? Negative 7 and positive 6 inclusive. It can be 6. So really, this is the preferred method. This is how I want to see it. I want you to start writing it like this. The other one I'll count. I can't count that wrong. But this is way better, and this is how you're going to see it, and I'm going to refer to it. And it makes sense. X is sandwiched between negative 7 and positive 6. So it makes it, it's sandwiched in there. So we're going to use this notation here. So we're going to use compound inequalities to solve these. All right, try this one on your own. Try both these on your own. See how you do. I'm going to post the steps here in a second. You can grade it, check it, see how it went. Good luck. All right, here we go. On the left side, I hope you recognize after you simplify it, this is a great or than over here. Solve it, and you get y is greater than or equal to 8, or it's less than or equal to 3 or 2. I'm sorry. So not too bad there. Shade it. Make sure you graph it. You're good to go. Right one's tricky. Hopefully you didn't freak out. Threw decimals in there. Just want to just use a calculator on these. But same thing. Simplify it down. Just be careful on this one because you're dividing by this negative 5 here. So it's going to flip your sign. So this actually turns out to be, it's a less than, it's an and. We're looking for the numbers between negative 4.62 and less than 8.34. So there's a compound inequality there showing that. Everything's sandwiched in there. Awesome. Very good. So before we go, oh, there's Mr. Kelly jumping in here with a little negative. Special cases. Some weird things can happen. I just want to make sure we're okay with it. So again, this one's already simplified down. So what happens if you simplify an absolute value down to this? Yeah, this is the one that both Kelly and Sullivan stressed on this. Absolute values can't equal negative numbers. But can they be greater than? Yes, in fact, they always are. So if this happens, if an absolute value is greater than this, what does this mean? This means everything works. This actually has infinite solutions or all solutions. Everything works here. So if you want to write infinite solutions, that would be awesome. If you didn't even know it, you could say, okay, this is a greater than, it's an or. You could actually solve this. But what's going to happen is you're going to get something crazy like, let's just go ahead and do it. Let's pretend we didn't catch it. It's great or than. So we flip the sign and make that positive. So when I do this, check out what's happened. Subtract your 1 from both sides. 2x is greater than negative 10. Or subtract your 1 over here. 2x is less than 8. So what does this mean? It means x is greater than negative 5. Or, divide by 2, x is less than 4. Well, if you're greater than negative 5 or less than 4, what happens on the number line is you just cross each other, don't you? Here's 0. Here's negative 5. Here's positive 4. If I didn't catch this, well, here's negative 5. Everything greater than, I'm shading right. Here's 4, circle everything shading left. But look, I went over my circle, so I filled it all in. It's really any solution here, infinite solutions, however you want to write it. Either way is cool. Everything works on this one. Awesome, so that's a special case. What about this? This one I wanted you to simplify a little bit first. Remember, we got to make sure the absolute value is by itself. So divide both sides by negative 3. And just make sure we're cool with that. When I divide by negative 3, it flips the sign. So be careful with your flipping here, and you get negative 3. So now it's the same idea. Here's an absolute value. It doesn't equal. It's less than a negative. Can an absolute value ever be negative? No. So could it be less than a negative? No way. This is definitely no solution. If you try to solve this one, you're going to get some errors and all this weird stuff. Hopefully you can recognize it here. You don't have to go any farther, but you can try to do it, but it's impossible. Cannot do it. So be careful of the special cases. Let's just solve it just in case you didn't catch it. For some reason you didn't catch it, you're going to catch it here because it's less than, so you're thinking it's an and you say 2x plus 1 is greater than positive 3. So when I solve this, subtract your 1 from both sides. 2x is less than negative 4. Subtract your 1 over here. 2x is greater than 2. So when I actually divide by 2, I'm saying x is less than negative 2, and what? And divide that by 2, x is greater than 1. Can you be less than negative 2 and at the same time greater than 1? No, it's impossible. You can't do that. So if that happens, that's our weird solution. Awesome. Excellent. That's it. I got a little clip for you here. I hope you don't run into any obstacles like this guy did on this master check. Hope it's smooth sailing for you. Good luck on the master check. Peace out.